We will start with an introduction to the oxidation stability. We will see a method, type of analysis, range of application. We will see how our oxy test that you can see here works. And I will leave the stage to Damiano, and with him we will see in detail application and results that we obtain throughout a different type of samples. So, when we talk about oxidation stability, we refer to the ability of fats to resist oxidation during the processing and storage. Oxidation is one of the main reactions that compromise quality of food, but not only, also cosmetic products, chemical products, and so on. And it involves oxygen reacting with sensitive components, such as, for example, lipid, pigments, and vitamins. These reactions lead to the deterioration of flavors, color, and of course, nutritional value. That's why oxidation stability is the key indicator not only of product quality, but also of its performance and shelf life. When we study shelf life, three main aspects come into play. In particular, we can categorize them into microbiological, organoleptical, and physical and chemical factors. In particular, when lipids undergo oxidation, several undesired effects appear. We start to see the formation, for example, of compounds responsible for rancid odors and unpleasant flavors, which strongly affect the sensory quality of food. This deterioration has a direct, of course, economic impact, since products may lose their market value or become unsellable. Moreover, some oxidation products may even pose a potential health risk to consumers. Therefore, understanding how and when oxidation occurs helps producers better predict and extend the life of their products, of course. The challenge is that the lipid oxidation occurs slowly at room temperature, sometimes taking days or even months, of course, before reaching a rancidity, a detectable rancidity. And traditionally, oxidation have been monitored using techniques such as peroxide value, anisine value, or free fatty acid. Since that, many accelerated methods have been developed to attain reliable results, but in shorter time. And for example, this category of tests are called accelerator shelf life tests, and this is where Oxidase method belongs. The Oxidase method allows us to simulate, we will see later, oxidative process under controlled condition, but drastically reducing time required to evaluate the shelf life of the product. In particular, the Oxidase method is not just fast, but it's also officially recognized. In particular, in 2017, it was established an EUAC International Standard Procedure, numbered CD12C16, for determination of oxidation stability in foods, oils, and fats. Moreover, it has been validated by Eurochem guidelines using a model system composed of silicon, oil, and fatty acid. So this ensures the method accuracy, reproducibility, and reliability, confirming that the Oxidase provides not only fast but also consistent results. And it is also versatile because it can be applied to a variety of matrices, not only food, we will see with Damiano, but also food, but also cosmetic, pharmaceutical, and chemical products, making this instrument a valuable tool for R&D laboratories, but also quality control teams across multiple industries. But how it works? The Oxidase measures the pressure change inside two independent and closed and thermostated chambers that you can see also in the picture labeled A and B. This pressure drop corresponds to the oxygen consumption caused by reactive components present in the sample that are mainly lipids and other oxidable compounds. And samples that can be solid, semi-solid, or liquid are placed in these titanium sample orders and then introduced into the chamber of our sample or of our instrument. The sample preparation with the oxytest, we will see later, that is extremely simple and fast without any previous fat extraction needed. In particular, for solid samples, a basic homogenization step is usually enough, while for liquid sample like oil, you can see here, simple stirring is generally sufficient. After that, the samples are weighted directly in the titanium holders, which are then loaded into the two chambers that, as we said before. Then, once the sample is placed inside the instrument, the oxytest applies pure oxygen at usually 6 bar pressure and maintains a constant temperature of around 90 degrees in the most of the cases of the analysis that we see later. These are the standard working conditions optimized to accelerate oxidation in most type of samples and application. At the end of the test, the oxytest provides an oxidation curve showing the relationship between pressure and time. From this curve, the instrument automatically identifies the induction period, also called IP, which represents the time required for oxidation to start, meaning that it is the moment when the sample reaches a level of detectable rancidity or when the oxidation rate suddenly increases. So therefore, the longer the oxidation period, the more stable the sample is against oxidation over time. All of this process is managed through Oxysoft, that is our software dedicated to control the instrument. This software, as you can see also from the picture, it's intuitive and user-friendly, allowing a full control of the test parameters. So real-time monitor, for example, of pressure and temperature, and of course, at the end of the analysis, instant calculation of the induction period. In addition, when the productivity of the laboratories needs to increase, we can connect up to 4 units for Oxytest to the same PC for a maximum flexibility while keeping each analysis completely independent. So, thank you for the attention. I leave the stage to Damiano, and with him we will see in detail application in food, feed, but also chemical and cosmetic application throughout different type of applications. So formula comparison test, estimated shelf life, and induction period during aging. Thank you for the attention.
Thank you, Mattia. Hello, my name is Damiano Cagnetti. I'm lab application specialist here in VELP, and today we will see some application about repeatability and formula comparison, estimated shelf life, and induction period. Oxytest is a very versatile instrument that allows to test different kinds of sample and metrics. Today, as first application, we will see meat and repeatability and formula comparison test. It is one of the main functions of the Oxytest reactor. Well, the instrument is capable to compare how different formulation of product can withstand to oxidation. Meat is rich in protein and fat, but also a very perishable product that the conservation of meat is crucial to avoid undesirable flavors, discoloration, and in general, loss of freshness. This is why frequently the producers add antioxidant to the meat to verify how the formulation of the product can change the oxidation status of the product. The oxidation has been performed into Oxytest reactor following AOCS CD12C16 method. To increase the repeatability of the results, a sample has been homogenized by grinding them by a cutting mill, and the procedure has been performed to help the distribution and the diffusion of the oxygen through the meat and to reach the fats contained into the meat. 10 grams of sample have been placed into the reactor batch, and the test condition were 80 Celsius degree and C bar and 6 bar. In this condition, the oxidation of the products is fastened, and the effects of different antioxidants to preserve the meat can be better appreciated. Samples have been tested in duplicate, and we can see that the instrument, the oxytest reactor generate as a different into the reacting chamber. There is the absorbance of oxygen, and that instrument can generate different graphics. We can see the typical bending curve that is generated when oxygen is progressively absorbed by the meat, so during the oxidation process. The induction period is the time calculated at the inflection point. For formulation F1, we can see an induction period of 7.5 hours, more or less. And for meat sample F2, we can see an induction period of more or less 5.5 hours. Is it possible to elaborate the oxidation curve obtained for each kind of meat? And the induction period was significantly longer for meat F1, and this demonstrates a higher capability to absorb oxygen from the environment, and so this information can be an added value that is very helpful for formulators and researchers. Have a clear indication about the better formulation to be used to enhance the shelf life of the product. Similar application, but different industries. Now we will see possible application of oxytest reactor applied to cosmetics, in particular, in this case, on cold wax strips. Cold wax strips are widely used for aerial removal, but the aging of the product due to oxygen exposure can cause color change and also loss of functionality. Also, for cosmetic, indeed, the determination of the shelf life of the product is very important to grant the quality of the products, and shelf life is highly influenced by formulation. In the study, different formulation of cold wax strips have been tested to find the better one. Test has been performed into oxytest reactor following AOCS. For the study, about 20 grams of sample has been tested as is, without separating or removing the wax layer. Sample have been inserted directly into oxytest titanium chamber, and the test was performed at 100 Celsius degree with a pressure of oxygen of 6 bar. Data have been automatically collected from Oxysoft, the specific software solution that controls oxytest reactor. The software is very intuitive and user-friendly and gives the operators the opportunity to set up different parameters. Operators can also follow the progress of the analysis from remote using Hermes Cloud Platform if needed. Grant the repeatability of the results, it's very important to manage to understand how to manage high viscosity sample like wax at hot condition. Each formulation has been tested in duplicate to verify the repeatability of the sample. As you can see in the graph above, each formulation has different oxidation profiles and show different bending curves with different induction period. Induction period for formulation 1 was about 4.5 hours. with a relative standard deviation of 5. For strip number 2, it's 17 hours, let's say, with a relative standard deviation of 2.4. And for strip number 3, it's 9 hours and a half with a relative standard deviation of 0.6. This indicates a longer time before the oxidation starts to occur for the formulation number 2. This higher resistance to oxidation indicates a superior stability and a longer shelf life for this formulation. A third example of application that gives an idea of how many different metrics can be investigated with oxy-test reactor is leather. Leather is one of the oldest crafts in human history. Beyond aesthetic and texture, in order to turn skin into leather, the product must be treated and stabilized. During this study, the effects of the antioxidant used during tanning process has been evaluated. Moreover, the induction period for a non-treated sample has been evaluated in parallel. The test has been performed by using oxy-test reactor according to AUCS method. Sample has been inserted directly into the oxy-test titanium chamber, and the test has been performed at 80 Celsius degree with a pressure of oxygen of 6 bar. Data have been automatically collected from the software. As in this case, to observe a visible oxidation flex, it is very important to take care about the test condition to see the flex point in the shortest time possible. Each sample has been tested in duplicate. As you can see in the graph above, sample has different oxidation profiles and show different bending curve with different induction period. As expected, with no antioxidants, the induction period is very short because there is no treatment on the surface of the leather that protects the leather itself. The induction period for the sample treated with antioxidant is way higher and demonstrate the ability of oxy-test to detect the oxidative stability of the sample. As we can see in the table, induction period for leather with no antioxidant is about 1 hour, and for the sample with antioxidant is about 24 hours. Also in this case, the oxidative stability performed with oxy-test test is a strong tool to enable time-saving stability studies to help the researchers in process identification for the product of the manufacturer. Now, let's see a different application available for oxy-test reactor to estimate the shelf life of the product in food and feed industry. Breadsticks are a bakery product very popular all over the world. Due to the presence of fats into breadstick recipe, this bakery product is very prone to oxidation over the time. The shelf life of the product is largely influenced by the formulation of the product itself, like we see before. Until now, we understood this concept, and now the question is it possible to estimate the shelf life of the product using the oxy-test reactor? Well, the answer is yes. Using the oxy-test, is it possible to simulate an accelerated aging of the sample and different temperature at different temperature, and estimate what should be the shelf life in a different temperature condition. In this study, about 30 grams of breadsticks have been grounded before the analysis to give homogeneity to the sample. 3 different oxidation tests have been performed with the same pressure of oxygen, 6 bar, but with different temperature, 80, 90, and 100 Celsius degree. The uptake of the oxygen into the chamber has been monitored from the software over the time to determine the induction period as function of time and temperature. The challenge here is to ensure homogeneity of the sample and managing volatile compounds who can influence pressure reading into the chamber. Oxidation stability of breadsticks show us as we can have different bending curve. The measured induction period has been plotted as function of temperature, and the equation of linear regression for the points has been calculated with an R square value of 0.9977. Using the equation obtained, it is possible to estimate the shelf life of the product at 25 Celsius degree, and that is approximately 1 year. This is a very powerful tool, since the shelf life of the product could be estimated taking account of different environmental conditions. Until now, we saw how oxidation stability can be a reliable indicator, very helpful for formulation of products and estimation of the shelf life of the product. But how the induction period can vary over time? During the last application of today, we will better understand something more about the so-called induction period to make more consideration about the method. During 2015, oxidation studies has been performed on tuna fillet oils. Tuna fillets are appreciated for highly quality protein, essential omega-3 fatty acid, and rich flavor. The addition of oil has two main functions: to enhance the sensory characteristic of the product and to help to preserve the product by limiting direct exposure to oxygen, reducing oxidation over the time. Using Oxitest reactor, we are able to evaluate the induction in the induction period and monitoring how induction period varies as the oxidative state of the sample varies. The analyses were conducted on 4 experimental groups. During the study, tuna fillets and oil have been evaluated separately at different aging time to evaluate how oxidation progresses over time. The content of the glass has been collected and drained to separate tuna from oil. Oil has been centrifuged to separate the residue of tuna. And the oxidation test has been performed at 90 degrees for oils and 100 degrees for tuna, with the same pressure of oxygen. Starting from the available sample, 4 experimental groups with different aging status have been created. For sample 1, the aging time was 6 months. For sample 2 was 3 years, 4 years for sample 3, and 8 years for sample 4. An induction period has been then measured in all experimental groups for both tuna and drained oils. The induction period of the oils in the graph above it's reported, and we can see that we make a parallel between a group of control that is fresh oil and fresh oil that have been submitted to the same process that the product has submitted, and a different group of preserving oil. The induction period for the control group is has the highest induction period, and this indicates especially for untreated oils that the oil has a great capability to absorb oxygen due to the low level of previous oxidation. For preserving oil group, we can see that the induction period decreases with the aging. Also, this information confirms that the ability of the oil to preserve the tuna from the oxidation decreases over the time due to the exposure to the oxygen. An opposite behavior we can observe for drained tuna. The induction period value increase over the aging of the sample, probably due to the fact that oil progressively permeates tuna fiber and protects the fish from oxidation. The data showed above clearly demonstrated the conservative effect of oil on tuna fish. The greater the oxidation stability, the longer the shelf life of the product. In the graph above, the induction period for oil in blue and for tuna fish in orange has been plotted. As so before, the induction period of the oil decreases over the time. The decreasing of these values during aging is due to progressive oxidation of the oil. This observation is expected since the role of the oil is to protect the tuna fish by absorbing oxygen over time. For aged oils, the capacity to buffer oxygen is reduced, as well as the value of the induction period. As a consequence, not only the freshness of the tuna is conserved, but we can see increased value of induction period for tuna fish over the time, probably due to the progressive diffusion of oil into the tuna fish fiber. In conclusion, when a fresh sample of tuna is removed from the preserving oil, it is more perishable than a long-aged tuna. This confirms manufacturers' declaration that tuna fillets in oil are better if consumed a few times after repackaging. Oxitest has proven to be a valid tool for measuring the degree of oxidation of tuna in oil, and all the data showed suggest that induction period can be used as a marker to assess aging status of tuna fillets in oil.
Thank you, Damiano, for your interesting presentation, and thank you all for the attention. We will answer to your question later as we are running out of time. So we will answer to you as soon as possible by email. And thank you for the attention, and stay tuned for our next webinars and events. Thank you very much.